All right, diving into this mountain of quantum computing stuff you've given us. Articles, videos, even your own notes, huh? Looks like you want to go deeper than just the buzzwords. Really get a handle on this tech.
Yeah, and that's it exactly. Not just skimming the surface here. I'm aiming for a deep dive. How these quantum computers work, what sets them apart, and what they might actually change out there in the world.
And from these notes, it seems like you're after the real-world impact, right? How this could change everyday life, not just the theoretical stuff.
Exactly. But to really get those applications, got to start with the basics. What even are these qubits we keep hearing about? How do they make quantum computers able to solve problems the kind that classical computers just can't even touch?
Well, there's this Cleo Abram video, and she's a pretty interesting analogy. Goes beyond just saying quantum computers are faster. She compares them to boats, actually.
Oats!
Yeah, like, they're not just better cars. Boats are for totally different terrain, right?
Mhm.
Or in this case, different problem spaces.
Ah, I see where you're going with this. That analogy is helpful, actually. It highlights how we're not talking about replacing classical computers, but having this whole new tool. Quantum computers are built for, like, navigating the murky waters of quantum mechanics. That's where classical computers just sink.
Okay, so we've got our quantum boats and this uncharted quantum ocean to explore.
Hmm.
But what makes this ocean so special? What kind of problems are uniquely suited to this type of computing?
Well, one of the biggest things is simulating nature itself. Like, think about it. The universe, at its core, it operates on quantum principles. And quantum computers, with their qubits doing the same thing, they're in the perfect position to understand, to predict how things work on that super tiny level, molecules and all that.
That's where it gets really mind-blowing. Like in drug discovery, Abram even gives this example. Imagine designing a drug with a quantum computer, one that targets a specific cancer cell based on your DNA, like personalized medicine.
Wow.
That could change medicine as we know it.
Right. It really could. And it goes way beyond medicine, too. Think material science. In that same video, one researcher mentions using quantum simulations to design a new catalyst, something that could make solar panels twice as efficient.
Seriously?
Yeah, we're talking solutions to some of the biggest problems humanity is facing.
Okay, starting to see why people are calling this a revolution. But there's this other side to it, right? Something about quantum computers and encryption. Sounds a little cloak and dagger.
Ah, yes, that. The potential for quantum computers to break the encryption we use every day is very real, and it's because of something called Shor's algorithm.
This is where I got a little lost, I have to admit. The video mentions Shor's algorithm cracking RSA encryption that's used everywhere online. But how does it actually work?
Okay, imagine RSA encryption is like a lock, and it has this massive number of possible combinations. Classical computers, they'd try each combination one by one, which would take, well, forever, basically. But Shor's algorithm, it exploits the weirdness of quantum mechanics, basically tries tons of combinations at the same time.
So it's not brute force, it's like a quantum shortcut.
Exactly. And while we don't have quantum computers powerful enough to actually break RSA today, the possibility is there. That's why researchers are scrambling to develop quantum-safe encryption.
And from what I gathered, those are like algorithms built to resist attacks, even from super powerful quantum computers. But makes you wonder, are we ready for this kind of shift?
A lot of people are asking that very question. Governments, research labs all over the world, they're pouring money into this because the stakes are so high.
So even if quantum computers aren't cracking codes tomorrow, it's not something we can just ignore. We need to be ready for a future where the encryption we rely on now, maybe it's just not enough.
Yeah, it's a fascinating situation, and yeah, a little unnerving. But even with the concerns, research into quantum-safe encryption is moving fast. It's not like we're just sitting ducks.
Okay, so a bit of a cybersecurity thriller unfolding alongside all this awesome potential. What I'm getting is, this isn't just about faster computers, it's a whole different ballgame.
You got it. We're at the very beginning of learning how to even use this new tool. Remember that researcher in the video? Said the problems they're working on now weren't even thinkable a couple of years ago. That's how fast things are changing.
Wow, that's both exciting and a little scary. Feels like to get the full picture, we need to go beyond just the what of quantum computers.
Yeah,
Got to understand the how.
you're right. And for that, we need to look at the specifics. How all these machines are built, the challenges, the potential they have for certain fields. Like, how are they actually going to change drug discovery or material science?
Sounds like we've got our work cut out for us.
Back again, continuing our deep dive into quantum computers. Before, we were talking about a tech revolution, how quantum computing's a real game changer, but to really get it, gotta look at the how behind all the wow.
Totally. Simulating nature, new drugs, changing material science, it all sounds amazing, but I keep wondering about the practical side. How do we go from the quantum computers we have now to those incredible applications?
That's where things get really down to the wire, qubit development, and all that. It's a fascinating story, actually. Remember that video, IBM's 433 qubit Osprey processor?
Yeah, that thing was huge.
That's the current record holder. But even that, it's nowhere near enough for the really complex stuff.
Oh, right. The researcher in that video, Olivia Lanes, she mentioned breaking encryption would probably need like 1 million qubits or more. That seems like a massive jump.
It is, but the progress is what's amazing. Lanes also said the problems they're solving now, they weren't even thinking about them a few years ago. The field's moving super fast, but it's not easy, trust me. There are some serious roadblocks they're hitting trying to get those higher qubit counts.
So what's stopping us from having these 1 million qubit machines making miracle materials and personalized meds already?
One of the biggest things is keeping these qubits stable. They're incredibly fragile, sensitive to any disturbance. Temperature changes, vibrations, anything can mess them up, make them lose their quantum state, and that throws off the whole calculation.
So why are they going to be kept so cold, right? Like colder than space, I think I remember.
Exactly. And just making that kind of environment, it's a huge feat of engineering in itself. It's like, I don't know, building a house of cards in a hurricane. But even with the difficulty, researchers are making some pretty impressive progress. They're figuring out new error correction techniques, improving the coherence times, which is basically how long the qubits can hold their quantum state.
So it's this balancing act, pushing the limits of what's possible, but also making sure these systems are stable and accurate. Seems like a monumental task.
It is. But the potential payoff, that's what's driving all this incredible innovation. Think back to those applications, the ones we talked about earlier. Where do you see quantum computers making the biggest impact soon? What really grabbed you?
You know, I have to say, that whole material science revolution thing, that really caught my attention. Designing materials with custom properties, even stuff we haven't thought of yet, it's crazy. Imagine solar panels way more efficient, or materials lighter than plastic but stronger than steel.
You're getting at the key point here. It's not just about copying what we already have. It's using quantum computers to go past the limits of our current materials, unlock possibilities we never even imagined. That's where the revolution is.
What about medical applications? We talked about personalized medicine, but are there other ways quantum computing could change healthcare?
Oh, absolutely. One area I find fascinating is using quantum computers to simulate biological processes, like at the molecular level. That could lead to a way deeper understanding of diseases like cancer, Alzheimer's, maybe even lead to better, more targeted treatments.
So like having a microscopic view into the body, seeing how diseases work, and figuring out how to stop them at their root.
That's a great way to put it. And don't forget about quantum imaging, too. Quantum sensors, they could revolutionize medical imaging, create devices way more sensitive and accurate than what we've got now.
Feels like we're on the edge of a medical revolution, where early, precise diagnosis is just normal. That could change how patients are treated, even save lives.
That's the goal, and the early research is looking really good. But with all this potential comes the responsibility to really think about the implications, right? We've got this powerful technology. What does that mean for us?
Yeah, you're right. We touched on this before, but it's worth digging deeper into those ethical questions. Any new tech this powerful, we have to consider both the good and the bad. Okay, so back to quantum computers. We've covered a lot, the basics, potential applications, even some of the challenges and ethical stuff. But before we wrap up, I'm really curious about the people, the organizations actually making this revolution happen. Seems like every week there's a new headline about some quantum breakthrough.
It's true. It's a really dynamic field right now, and you're right to focus on the people involved because this isn't just happening in universities. There's a whole global race going on to get to quantum supremacy. Basically, building a quantum computer that can beat any regular computer on a specific task.
Yeah, that video really focused on IBM and what they're doing. We even saw their 433 qubit Osprey processor. That was impressive. But they're not the only ones working on this, right?
Oh, not even close. You mentioned Google. They made a big splash a few years back claiming they hit quantum supremacy with their Sycamore processor. And beyond the big names, there's Microsoft, Intel, tons of startups. Everyone wants in on this.
And it's not just companies either. The video talked about how governments are getting involved too. Sounds like the US, China, the EU, they're all investing heavily in quantum research.
For sure. It's seen as strategically important,
Right.
impacts everything from national security to like who's ahead in the global economy. What's interesting is all this competition, it's actually pushing a lot of the innovation we're seeing.
So it's not just about building a bigger, faster quantum computer. It's about trying different things, different types of qubits, even different ways of thinking about computation.
Absolutely, and that's what makes it so exciting. Remember how the video mentioned different types of qubits? Superconducting, trapped ion, photonic, they all have their advantages and disadvantages. It's too early to say which one will be the winner.
Like the early days of the internet.
Yeah,
Right. All these different technologies fighting to be the standard. Who knows what the quantum computing landscape will even look like 10 years from now?
exactly. That's the beauty of it. We're just at the beginning, and the possibilities are endless, really. One of the researchers in the videos said something that stuck with me. They said, the world is quantum mechanical. It made me realize we're not just building computers, we're tapping into something fundamental about reality itself.
Whoa. Yeah, it's like opening a door to a whole new understanding of the universe. And what we find on the other side, it could change everything.
Couldn't said it better myself. Quantum computing could revolutionize everything, not just specific industries, but our whole understanding of how the world works.
Well, this deep dive has been a wild ride. We started with a pile of articles and videos and ended up exploring the very nature of reality. Learned about qubits, algorithms, all these potential applications that sound straight out of sci-fi, even tackled the ethical questions that come with this powerful technology.
And honestly, we've just scratched the surface. As quantum computing keeps developing, we can expect even more amazing discoveries and applications, things we can't even imagine right now.
It really is a transformative technology, could reshape our world in huge ways. So as you continue exploring this incredible field, here's a final thought. If quantum computers can help us unlock the mysteries of the universe, what other impossible challenges might they help us overcome? And what role will you play in this exciting new era?